theta double dot. So these are the straight applications of what we had for polar coordinates. But it's true that you had to think about this part. This part was important. Now the last part, I agree, we had not done something like that where you have to show that the velocity was tangent. That's true, but it was, this one was 3 points out of all of the points for the exam. It's actually not very difficult. I give you in the solution maybe a long way because I'm thinking that's what you might think of doing, but it can be done very shortly if you work in the UR U theta frame, you see? So you have U theta on UR like this. And let's say you have the curve that's doing this. For instance, the profile of the cam. So how do you get the slope of this? John, when we think of the slope, it's with respect to x and y. But we could compute the slope with respect to U theta on UR. Why not? So if you do this, the slope would be given by, for instance, this angle, the tangent of this angle. Now we don't call this a slope, of course, because it's not a dy over dx. And so what do you need? You will need this length on that length, and you will take the ratio of it. So let's say you're at r theta here. So this would be theta, and this length would be r. Then where would you be at the other point here, which is really nearby? Well, it would be on r plus dr on the theta plus d theta. So what would be this distance? In terms of r, d theta, dr, and so on.
Magnitude of
this one, you see, the little one. I don't know if you can see it very well. Is this an increase in theta or an increase in r?
an increase in R.
The increase in r. So that little distance here, let me draw it bigger. So that distance here would be a dr. And what would be that distance here about? What did you say?
D theta.
D theta is not a distance. D theta is an angle. But if you think about it, you see you have r here, and then, so with the angle theta, and then when I go here, I'm going to have here d theta. So what could be this distance here?
dr d theta.
It's not dr d theta. That's how much do you? This is like moving along the circle of radius r. So what would be the distance?
Oh, R d.
R d theta. So now, if you think of what the angle is going to be, well, I can compute the tangent. And the tangent is opposite over adjacent. So you would get a dr over r d theta. So that's what the slope would be. But now, how do you relate this to the velocity? Well, you can write this in the form of dr dt. If I divide by dt upstairs and downstairs, on r d theta dt, which is r dot over r theta dot, which is vr over v theta. So then, obviously, the velocity is tangent to the curve. Because if you take the velocity vector has to be something that is like this, because it has a a VR and a V theta whose ratio is equal to the slope of the curve. So no matter what, it's going to be the case, which is, of course, normal, as you might expect. So Brahma, Albert, not here yet. Oh yeah, you are. Sorry. You are hiding behind Felix. So, that's what was going on. And for the last problem, it was important to say for the length that it was the differences between, for instance, SB, SC. Interestingly, Vince is not here. He's in DC today. Told me he was going to the inauguration. So, but Vince and Colin built it in the lab. So they had 3 blocks with pulleys, and you could tell that by moving, for instance, block B, I think it was, you had block C moving 4 times as much when A is fixed. So it was an interesting setup. You don't have it anymore, right? It's been disassembled.
We took it apart, but it's really easy to put together.
Okay, so maybe you could bring it tomorrow and just show it to the class. Something interesting, and you see that when you move one block, the other one is moving much faster. So it's an interesting design. Okay, so it was a tough one, I agree. So, but there are other quizzes coming up, and there are plenty of opportunities to make up your score if you didn't do well. Some people did well, and the highest score is 18.
What's the average?
The average is, it was a 12.5. So it's a bit low because it's a 2.5. So it's better when the average is at 3.0. So it shows me that it was a difficult test. And at the end of the quarter, if I might not count this one as heavily as the other one, depending on what the other ones are like. So enjoy the average for the class. At the end of the quarter, I always put it around 3.0. So if it's at 2.5, of course, I would bring it up. But we have lots of quizzes coming up. So. Okay, let me give you back your homework. So for the homework, it's mostly for me to take attendance because you have the solution. So I give you a check mark if you did it, and you get 1 point. That is 100%.
Nên làm không đủ cũng đừng có đưa bài cho thầy là thầy check lên thôi.
Mà cái homework nó sách
Tại vì solution của thầy quá các bạn đó, tự nhiên không phải thầy dạy.
cái đó là cái 11 edition, cái này có thêm thôi. Tại vì mình có đa số bạn cái gì trang của 11. Cái khác xíu.
Đọc solution cũng nhiều có nhiều hơn.
Gợi ý.
Không dạy chuyện mình làm mình hỏi dạy.
Brian. The one you
Bài
okay, so make sure you tell
Làm luôn mấy cái recommend solution cũng không biết làm phải quiz. Làm luôn mấy cái require luôn đâu làm cái bằng cái quiz nó khó quá, từ thầy cho mấy bài giống vậy ai ngờ cho mấy bài khác hết trơn.
And Josh.
Có về này đúng rồi, về khó cho mấy người trước. Nó chứ không cho mày khó như vậy.
Okay, so now that we have looked at, well, reviewed and looked at more details at kinematics, let's move on to the next chapter, and it's going to be forces. Because of course, you know that we can relate force and acceleration via F is equal to ma.